So in this example, we're going to look at the manual calculation of Pearson's product moment correlation coefficient for the data that was in example 1 with the outlier removed. Now, remember, you do not need to know how to do this. This is just for your understanding of how this works. So notice that we've got the x minus x bar and the y minus y bar here, and over here, x minus x bar times y minus y bar. The x bar is the mean of the x values. So in other words, we've just added these x values up. There's 16 values, so added them up and divided by 16. And before we started, I actually did that, and there is your value there. Same thing for the y's, add all of those up, divide by 16, and you get 10.375. So x minus x bar means taking each x value, so in the first instance for student A, 2, and subtracting 4.6875. That's what x minus x bar means. So that first one there is negative 2.6875. And then the next one is 4 take away 4.6875, giving us negative 0.6875. We're going to do the same thing for the y's. So my first one there is going to be 8 take away 10.375, which gives me negative 2.375. And you really don't need to sit and watch me do all of those. So I'm going to stop recording now and fill all of those in. While I was paused and computing the rest of those values, I just brought in the formula over here as well, so we can try and explain what's going on as we go. Now, an important point which every line of best fit through the data should go through is the mean point, x bar, y bar. For our particular case, we know the x bar is 4.6875, y bar is 10.375. If we look at student A, 2, 8, that piece of data is to the left and down from x bar, y bar, which means our x minus x bar is negative, as we can see up here, negative 2.6875, and the y minus y bar is also negative. Now, these points can be to the right and down, and that would make x minus x bar positive and y minus y bar negative. Or they could be left and up, which means that the x minus x bar would be negative and y minus y bar positive. Or they could be right and up, in which case both x minus x bar and y minus y bar are positive. Now, in the case where they're both negative, when we multiply them, we get a positive answer. In this case, 6.38281. That's what you get when you multiply negative 2.6875 and negative 2.375. Now, when you look at the formula, if that sum is positive, we end up with a positive correlation. If that sum is negative, you end up with a negative correlation because the bottom must be positive. We've got squared quantities in here, and we're taking a square root, which is going to return a positive. So whether we have a positive or negative correlation all depends on the top. So if most points are actually down here or up here, then we end up with both negative, which gives us a positive, or both positive, which gives us a positive. So when we get a positive correlation, most of the points are lining up this way. Hopefully that makes sense in conjunction with what we've said before. So that first one was 6.38281. The next one, when we multiply those, is 2.32031. And I'm going to pause again and fill in the rest of those values. So I've completed all of the values now, And if we add up that column, we get 55.875. Now, we also need to square each of these values and then add them up. So if we do that, we end up with 47.4375. And we also need to square each of these values and add them up at the bottom there. And if we do that, we get 97.75. So now, following our formula, our R is going to be 55.875 divided by the square root of 47.4375 times 97.75. And if we do that, we get 0.82, which is a nice, strong correlation, strong positive correlation.